Lens maker's formula. Lens maker's formula is written as 1 by f is equal to mu minus 1 into 1 by r1 minus 1 by r2. So the lens maker's formula gives the relation between focal length of a lens, refractive index of the lens, and the radius curvature of its both the surfaces. So we make some assumption in deriving the lens formula. First is the aperture is small. That is, aperture of the lens is small. Aperture of the lens is small, and thin lens we are using. We are using in deriving this formula, that is a lens maker's formula. Thin lens we are using, and the object is point size object, and the object lies on the principal axis. Object lies on the principal axis. The incident ray and refracted ray. The incident ray and refracted ray makes small angle with principal axis. So these are the four assumptions we are making. Now the new Cartesian sign convention, new Cartesian sign convention. New Cartesian sign convention, this is the lens, maybe concave or convex. This is optic center. This is the redirection and incident on the optic medium. It may be convex or concave. So we are talking in general. This is the direction of ray, and then all the distance are measured from the optical center. And if you are measuring distance against the ray direction, say this distance d1, then it is taken as negative distance. That is, if you are measuring from optic center against the ray direction, that is negative distance. If you are measuring from along the ray direction, this is the ray direction. If you are measuring it along the ray direction, this distance d2 is considered as positive. So with this assumption, we derive the lens maker's formula. These are the assumption we make it for deriving the lens maker's formula. Consider a convex lens. This is a convex lens, and having its optical center here. This is the principal axis. So we kept object is a point object kept at, this is object, and this is optical center, and a ray from the object will go and strike here, incident here, and another ray will go like this. We need two rays from the object to locate the image. Now, first refraction. This is the surface 1 of the lens. This is surface 2 of the lens. Its radius of curvature will be here. So this radius of curvature for this one, first surface. This is the radius of curvature. Say R1 for this one. This is the radius of curvature for the second surface. So we call it as R2. So R1, we are measuring R1. This is the from optical center. R1 is positive because from here we are going. This is R1, so positive, and R2 from here we are going this way, this is negative. R1 and R2 is negative. So first refraction, so this is X, P1, Y, this is P2. First refraction takes at the surface X, P1, Y. At X, P1 and Y. It is happening. So here, when first refraction taking at XY. So this is, we can say this is the denser medium. This is a rarer medium, air. This is also a rarer medium. So at first refraction, the refraction takes place from rarer to denser. Rarer to denser. It means the ray, the incident ray will bend towards the normal. The incident ray will bend towards the normal. This, as we know it very well. Now in this incident, so it means we will draw a normal. For this one, the center of curvature will be here. So we will draw this is center of curvature of the first surface, C1. So we draw the normal like this. For the normal for the first surface, because it is incident at this point. So at this point, after incidence, the ray is likely to go this way. We expect the ray to go straight away in this fashion, but since it is rarer to denser medium, the ray, instead of going like this, it will burn towards the normal, this normal. This is the normal, it will burn towards the normal, and it will go and strike it here. Let's see on the principal axis, this is I1. Why it is, this is here, ray is going from here, this ray is going from here, this is going here. This will be a real image. Therefore, real image is formed. Image is formed at I1. So this distance from the optic center, we say this is V dash, I dash and V dash, V dash. But now here, this will go and strike here if this surface is not available, if not there. It means because of this surface, it will undergo one more refraction. So what we'll see, now we consider if the medium is continuous. It means the ray will come and form the image at this place. If the ray is continuous, means we can say only this surface is available and the medium is continuous. This is not there. Assume that this is not there. So if it is going, then it will form here. So I dash. But the actual problem, what is the ray? Here also there is one more surface. This is denser medium, rarer medium. Here also it will undergo refraction. It will undergo refraction. If we have the image is formed here, considering that is this surface is continuous medium, then only it will strike. So for the first medium, the image is formed at I1. Now, where we will get for the refraction to take place in the second surface, we need an object, then only we can get image. So where we will get the image, where we will get the object, this serves as the virtual object, because from here the rays are coming like this, rays are coming like this, and after refraction it will form again, this virtual object will form image at this point. Therefore, there is another surface, spherical surface at X, P2, Y. The image formed I1 acts as virtual object. It is real image formed here, but this real image is formed as acts as a virtual object for this surface for refraction to take place. Image formed item acts as virtual object. You know the concept of virtual object. If the ray is diverging away, then it is virtual object. When the ray is actually converging, then the image is formed as a real image. So this image formed as acts as a virtual object. It means when the rays from virtual object comes here after refraction. So the refraction at the second surface. What will happen in the second surface? Here there is it is happening from denser medium to rarer. This is denser, this is rarer. So refraction takes at this boundary. So it is from denser to rarer. Denser to mean the incident ray will bend away from normal. So when it is bending away from normal, when the rays are coming like this, it should go like this. Here we will take, so at this point we have to draw normal. Normal drawing means simply from that point of incident extend up to the center of curvature for that surface. This is C2 for surface 2. This is center of curvature 2. So it means the ray, instead of going like this, this is the normal, this is the ray direction. Instead of bending, this ray will bend away from this normal like this. So ray will come and strike here, forming the image. We call the image formed as I. It will be a real image. So we have to take consideration of two things. One is normal and bend away from normal, forming image at I. Now, refraction for the first surface. Already we have seen the refraction from the spherical surfaces, rarer to denser, denser to rarer. First, we'll take this is rarer to denser. The refraction, first refraction is taking place by formula. Refraction at spherical surface. Spherical surface. For the spherical surface, first is happening from rarer to denser. Further, the formula is we write 1 by V minus U is equal to, for the first surface, radius of curvature is R1. This is for the surface, radius of curvature is R1 divided by R1. From rarer to denser, what you will do, you will write the refractive index of the denser medium, that is lens. Refractive index of the denser medium minus refractive index of the rarer medium, that is here, and subtract these two. mu2 minus mu1. This is the first formula for first refraction. Now for the second refraction, see here V. What is V? V is equal to V dash. For the first refraction, the image is formed is at here. That distance is equal to V. So V is equal to V dash and U is equal to U, because this distance is U for the first refraction. Because first refraction, this is the object and the distance is measured from the optical center. So for the first image is formed here, first refraction, that we take as V2. So V, in this formula, V is equal to V dash, U is equal to U. So we can write it as mu2 by V is equal to V dash minus mu1 by U is equal to mu2 minus mu1 by R1. So this is the equation number 1. For the second refraction, and that is at this surface. So where is the object? Object is here, from the optic center from here, which is nothing but V dash. So object distance is equal to V dash. Note carefully the virtual object for the second surface. The image formed here acts as a virtual object. Real image acts as a virtual object. So the object distance is from the optical center is V dash. V is equal to V dash. And what is V? V is equal to the image is formed here. This distance we write it as V. At I it is forming, so we can treat it. So V is equal to V only. So second diffraction how we write? 1 by V minus U is equal to refract radius of curvature of the second medium, and reverse this one. That is, instead of mu2 put mu1 here, put mu2, subtract this both. Mu1 minus mu2. This is the second diffraction because it is happening from denser to rarer, and the spherical mirror formula is this one. First formula, simply reverse it. So mu2 is equal to refractive index of denser medium is equal to mu, we can say mu, refractive index or mu refractive index of lens is equal to simply refractive index of the medium. For first surface is refractive index of air is equal to 1. This we can consider now. This is equation number 2. Adding equation number 1 and equation number 2. This becomes mu2 by V dash minus mu1 by U, add this also, plus this one, mu1 by V minus mu2 by U. Sorry, this here, the U. U is V dash. U is equal to V dash by V dash is equal to, add this one, mu2 minus mu1 by R1 plus mu1 minus mu2 by R2. So this and this get cancelled. This becomes mu1 into 1 by V minus 1 by U is equal to, this we can change it as like this. See, mu1 minus mu2 by R can be written as minus of mu2 minus mu1 by R2. The sign minus mu2 is here, plus mu1 is here. So this we can write mu2 minus mu1 by R1 minus mu2 minus v1 by R2, because this we want to make both the terms same. To make both the terms same. When adding these two, so this will become mu1 into 1 by V minus 1 by U is equal to, we can take common mu2 minus mu1 out, and this out. When we take this out, this become 1 by R1 minus 1 by R2. So this is mu1. Take this mu1 that side. 1 by V minus 1 by U is equal to mu2 minus mu1 by mu1 into 1 by R1 minus 1 by R2. Therefore, 1 by V minus 1 by U is equal to mu2 by v1. So this is nothing but refractive index of denser medium minus refractive index of rarer medium, or refractive index of glass, refractive index of air, we can write. So mu2 is equal to refractive index of glass. This is refractive, which we can call it as refractive index of glass is equal to mu. Mu1 is equal to refractive index of air, which is equal to 1. So this equation we can raise mu2 by mu1, this will become mu2 by mu1 minus 1 into 1 by R1 minus 1 by R2. So what is mu2 by mu1? Denser, rarer, so we can write refractive index of medium, that is glass, by 1, refractive index 1 is 1, minus 1, or simply we can write this way also, refractive index of glass with respect to refractive index of air minus 1, tensor error, into 1 by R1 minus 1 by R2. Refractive index of glass, or we can write refractive index of glass with respect to air minus 1 into 1 by R1 minus 1 by R2. Right? So refractive index of glass with respect to air, this is mu, this is 1. So or simply we can write mu minus 1 into 1 by R1 minus 1 by R2. This is 1 by V minus 1 by U. 1 by V minus 1 by U is nothing but focal length, 1 by focal length, which is nothing but 1 by focal length. This way also we can see, or we can write 1 by focal length is equal to mu minus 1 into 1 by R1 minus 1 by R2. We can write like this also, but as let us go. If his object is kept at infinity, if object is at infinity, that means object distance is equal to infinity. When object is kept at infinity for convex lens, it will form at the focus. It will form as the focus. Then where the image is formed at the focus. This is U at infinity. So image, that is image distance is, here is image is formed. So this F is equal to V. So we can take this way also. So this 1 by V is equal to 1 by F, since V is equal to focal length. 1 by F minus 1 by infinity is equal to mu minus 1 into 1 by R1 minus 1 by R2. Or simply we can write 1 by focal length is equal to refractive index of the medium minus 1 into 1 by R1 minus 1 by R2.